Okay. 1.6 exponents. So the goal today, I'm not going to rush through exponents because it's a lot of new information. I literally just taught 6th grade exponents. I know what you guys were taught last year. It's very minimum, very minimum. This takes it from very minimum to, oh my word, what the heck is this? Okay, so that's what you're doing today. It's a whole lot of information in one section. So what I do is I break it into 2 days. We're going to go slow today. So, of course, there's not going to be any homework. I am not assigning homework tonight. So kick back and relax. Take everything I write, you need to write. Because you're going to be referring back to this a whole lot. You'll eventually get it. Trust me. I've never had a student that didn't. They may not do well on a test or quiz or something. That's because they're not studying. But by the end of the year, they get it. 8th grade, they're learning the same stuff today, but it's a review of what y'all are doing. So they already have spent a year going over the stuff. They're going to know it. You know what I'm saying? It's just going to be brushing up on skills. All right, so again, if you need to practice to get better at things, here you go. Proto-page, pre-algebra, and chapter 1. And in chapter 1, we have a ton of exponent practice. Okay? Lots of it. All right. So stay awake. All right, exponent. Indicates how many times a number is used as a repeated factor. Basically, that says how. How many times the base, and I'll explain what the base is multiplied by itself. I'll let y'all catch up. So exponent, it indicates how many times a number is used as a repeated factor. Blah, 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 blah. Basically, how many times the base, the big number, is multiplied by itself. Okay, for example, 2 to the power of 4. This, children, is your exponent. But y'all probably already knew that. Exponent, that little number up there. This is your base. Now, you are going to hear me refer to this as the base a lot. So you need to know when I'm talking about base, that's what I'm talking about, the big number. Okay? So base is the big number. Exponent is that little guy there. And what this is basically saying, and I got to tell you, 6th grade, they're so cute. When I taught this the other day, they're like, well, yeah, that makes sense. Okay, get started. And it never fails. They'll give me 2 times 4 is 8. No. It's not 2 times 4. It's 2 times 2, times 2, times 2, 4 times. So it's the base times itself, however, whatever the exponent is. So it's 2 times 2, okay. Now, I will tell you, even my 8th graders in Algebra 1, they know this. They've had 3 years of it. But when they're deep in math and not focusing, they'll give me 2 times 4. And that's not right. So, what is 2 times 2? Italia? What is 4 times 2? What is 8 times 2?
16.
So this is 16. And again, the 6th graders are just now kind of being introduced to it all. And they're like, oh, that's so easy. And I'm like, I know, right? And then they start doing their homework and they'd be doing really good. And then all of a sudden I'd come across someone that gave me 8. And it's the reason I'm saying that is because it's a simple mistake. Because you guys have been trained to multiply. So when I have a 2 and a 4, and you know in your brain we're doing some multiplying, you just without thinking you go 2 times 4. It's gonna happen. Even my honor students will make a slip up and they'll start laughing. They're all embarrassed, okay? So it's 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. Does that make sense? Yes, ma'am.
Another way I do 2 to the power 4. So I do 2 times 2 is 4. 2 times 2 is 4, and then I.
Okay, that's correct. That's what some of the 6th graders are doing. They were doing that. They were like, okay, this is 4. This is 4, and then they'd give me 8. No, we don't add the 2. See what I'm talking about? They just want to get to that 8. We multiply, and then you get 16. So yes, Tanner, that is exactly. I think the problem that they did was 10. 10 times 10 times 10 times 10. They kept giving me 100, or they'd give me 200, or 100,000. They could not get it there. And I'm like, okay, boys and girls. And there's only boys. And as soon as I wrote it out, they were like, oh my gosh. And I'm like, exactly. Relax. Focus on the detail here. Yes, Italia.
Isn't 2 to the 4th power equal to 4 to the 2nd power?
Yeah. Yep. Okay. Star. There's a star. If no exponent, this is important. If no exponent is there, you assume it is a 1. This is very, very, very important. And I'll tell you, kids will sometimes mess up here more than they do with 2 times 4. If there's no exponent there, you're going to pretend there's a 1. And you're like, well, why does it matter? It will. Because you're going to be doing some adding and subtracting and stuff of exponents pretty soon. And you're going to need to know that there's a 1 there. Okay?
Just it times,
Huh?
isn't that just the number times 1?
You'll see. But you got to remember that there's a 1 there if there's no exponent. For example, let's say I have 2. Then that would be 2 to the 1st power. If I have a 3, that is 3 to the 1st power. What if I have 139 to the 1st power? That would be
139.
Do y'all understand? So anytime you see, or how about if I have A? What's its exponent? Someone? Tanner?
1.
A to the 1st power. Very good. So it same with even letters or variables is what they're called. If there's no exponent, we're going to assume all the time that there's one. Got it? Okay, so next star. See, it's going to be nonstop information. 0 exponents. Okay, for example, I don't have to write any words. Y'all ready for this? If I have 2 to the power of 0, you know what that answer is, Natalia?
1.
1. It is always 1.
I was going to say 0.
Learned that last year.
I was going to say, I just taught the 6th graders this. I'm excited to see that you guys are remembering. 45 to the power of 0 will be?
1.
How about x to the power of 0, Joseph?
1.
There you go. So any number or letter to the power of 0 will just be 1. Now let me show you this. This is going to blow your minds. What if I have -3 to the power of 2 to the power of 4 all to the power of 0? That's supposed to be a 0.
That's a lot of information.
Let me rewrite that because that's a mess. I'm sorry. -3 to the power of 2. I did this to my students last year, and they were like, "Oh, Mrs. Rogers."
I think I know the answer.
Madeline,
1. Yeah.
it's 1.
You said it's all to the power of 0.
That's right. It's
That's
all
what
to the power of 0.
That's the first thing I was sitting here
So
thinking
do you
about.
see this now? Here, this is a perfect example of algebra. I want you to look at this. That's ugly. I mean, in a way, when you first look at it, that's a lot of information, and some people may stress out when they see this. Okay, I got this. And they're freaking out. That little 0 makes the whole answer 1. Isn't that insane? So that tells you right there that sometimes just because the problem looks ugly doesn't mean it is ugly. Don't judge a book by its cover. Okay, any questions? My watch is telling me it's time to stand. I've been sitting too long. Okay. Star. If the exponent is a 2, it is called squared.
Oh, yeah.
For example, and you can still say 4 to the power of 2. I mean, that's not wrong.
What about 4 to the second power?
4 to the second power. All of that's perfectly fine. But if someone said, what is 4 squared? You would need to know that that's saying 4 squared. Which means 4 times 4, which is 16.
Not that bad.
No, that's what I'm saying. It's a lot of information. It's not bad. It's a lot. And we're still on the front side of the first page.
Can't deal with this.
Yes, you can.
Not that bad.
Just wait.
Too many numbers.
Just wait. Just you wait.
I'm scared.
No, we take baby steps into this stuff. I want to make sure you guys get it. I don't want to like rush through it and cram it all in for y'all to have homework tonight and stuff like that. I'd rather take our time today, and tomorrow kind of do a few more examples, review, and then I'll give you your work.
See who's cool with just crowd on there and be like,
No.
here's the work. Here's the work.
He does not.
Here you go. Then you gotta do this.
Yeah. He
Okay.
does. He actually does do that.
Well, as long as we don't have to shut down for COVID or hurricanes,
Is that enough space for this, you think?
Yeah.
Okay.
as long as we don't have to shut down for a freeze, hurricane, or COVID, we're going to be fine. Last year we shut down for 2 hurricanes, COVID twice, and a freeze for a week.
Same with us.
And one
No, I know, that's what I'm saying. All of us did. So and if my students last year could get through all the material with all of those interruptions, you guys can too.
but-
I know.
But also, one of the hurricanes didn't even happen.
Yeah, but we can't take that chance. I'd rather be safe and it not show up here
Would
than.
not be safe in a
That's right.
I
mean-
tornado to happen.
No, you don't.
No.
You
I
do
remember
not.
when that hurricane was
But
supposed to come, I was kind of like
I
chilling
wasn't
there
there when
on
we let
Discord with my
tornado.
friend, like,
Yeah.
okay.
Yeah, it's
Honestly,
better to be
and
safe
during
than
the
sorry.
freeze,
I wanna
whenever the
see
internet
tornado
came
in
back or
person.
like the power,
I've seen a
I would
water
just
spout.
get on Discord and talk to my friends.
Like a tornado
Just
in the water.
complaining.
We had a generator, so we never lost
We
anything.
were on a
You
cruise ship.
see, my grandpa died, and the rest of us don't know how to work a generator.
Oh,
Look it
okay.
up.
Next time you call us, we'll come take care of it. All right. If the exponent, because I mean during that freeze, we were helping all the neighbors with their generators and stuff like that.
Is it only
Yeah,
for
we
covered
just-
lots?
Like, we were just kind of chilling in the living room.
But seriously,
We went
guys,
outside to mess around.
seriously, if y'all ever need anything, you let me know. I'm very serious, man. Okay, if the exponent is a 3, it is called. Anyone remember?
Cute.
Yeah.
Raise your hand, young lady.
I had to think about it.
Cubed. Good job. Cubed. Example. 5 cubed is said as 5 cubed. 5 to the power 3 or 5 to the 3rd power is 5 cubed, which is 5 times 5 times 5, which is 125. There's a hurricane coming once in Mr. Stahl. Y'all remember Mr. and Mrs. Stahl?
No.
Their generator wouldn't start. And they called me. And my husband and I went over there, and Allie and Zachary, because they were principal here, you know. Allie and Zachary were like, oh my gosh, we're going to the principal's house. Yep. Took his generator, got it to working.
I knew Mrs. Stahl.
Yeah.
But I only know her for like a couple of days because it was her last year there. Well, she was retiring,
Yeah.
passing the torch.
So,
Mrs. Stoll was mean to me. Mr. Stoll was really nice though.
She seemed like she'd be kind of mean, but I don't know.
She was.
okay.
Mr. Stoll was really nice though.
This girl was really calm.
Some people
Artiste.
like Mrs. Stahl more than they did Mr. Stahl, so I guess it's just personal preference. All right, y'all got that?
Yeah.
I loved them both. Okay. Variable.
Now they're gonna haunt us all watching the video.
Not me, because they know I love them. They went to Nashville, Tennessee this summer and brought Zachary back an Elvis mug because they knew he loved Elvis. They're so
I had the same
sweet.
birthday as Elvis.
Do you really?
Yeah.
That's cool. Okay, variable. Do y'all know what a variable is?
I've heard of it.
There's a bunch of TikTok stars.
Joseph, do you know what a variable is? Huh?
Heard of it?
Madeline?
Can't remember. I know what it is.
I know
Can't
y'all
remember
know.
off the top of my head.
Okay, here we go. It is a symbol used to represent an unknown.
Oh yeah, it's letters.
It's a symbol used to represent an unknown number. Basically, it's the letters. And really, it doesn't have to be just letters in algebra. For example, x plus 4 equals 7.
X equals
X equals what?
3.
3. The variable is x. It is a symbol used to represent an unknown number. We don't know what x is. Well, yeah, we do because we can figure it out. But we may not always know. Okay? There's going to be times in algebra that we have no idea what the letter is, and that's okay. Sometimes in algebra, x could be anywhere from negative 50 to positive 50. You know, it may not be just one number. It could be a whole range of numbers. But either way, x represents the unknown number. But it clearly says the definition, a symbol used to represent. So, could this be a variable?
No.
Can it really?
Yes, it can.
Cool. I'm gonna do that.
Well, no. All it says is a symbol used to represent an unknown number.
Heart.
We could say a heart. That is a variable. Variables are symbols used to represent an unknown number. Now, in the world of algebra, we actually do use letters. Typically X and Y, but any letter can be used. Now, I will tell you, years ago, my old school, I had a 7th grader, and he was freaking out. Like, freaking out. He was near tears and everything. And he came to me, I wasn't his math teacher at the time. I was study hall for him. And he came to me, and I was like, what is going on? And he was like freaking out. He goes, I don't get it, I don't get it. And he was freaking out over the letter. Just looking at that letter gave him anxiety. So I started doing this with him. And he kind of laughed, and he goes, okay. So we started using that at first. And I said, do you still have the anxiety? He goes, I do, but it's not as bad. And I said, okay, don't let the letters upset you. It can be anything there. So don't let the letters upset you. All right, here we go. Moving right along. So do we know what variables are?
Yeah.
All right. So already we've learned quite a bit. There's 2 different forms that we're going to go over. More information. Form number 1 is the exponential form. Exponential form. Notice the word exponent. Y'all see how it has exponent in there?
Ew.
So, exponential form is this. That's exponential form, where you write it with an exponent. If I had another example, x times x times x, how would I write that? Joseph, how would I write that?
X cubed.
X cubed, very good. That is your that's a terrible arrow. That is your exponential form. This whole thing here and this whole thing here. So you're writing it with a base and an exponent. Makes sense?
My arrow ended up just like yours.
It's kind of like a wishbone.
Yeah.
Huh?
That's what I thought when I looked at it.
Wishbone.
Oh. Any questions on exponential form? All right, the second form is what's called expanded form.
I've heard of that.
I've heard of
Fifth
that,
grade.
too. Third grade.
Yeah, didn't know that in 5th grade.
So, what is it then?
I don't remember.
Talking.
It's the x times x times x.
Bingo. Let's say it's x to the 5th power,
X times x times x.
or I mean 6 to the 5th power, 6 times 6 times 6, 6, and 6. This is your expanded form.
That's weird looking.
My 6 to the 5th power looks like a 65.
I don't like it.
How about 5 squared? What's the expanded form, Tanner?
5 times 5.
Okay, and then what's that answer, Tanner?
25.
Perfecto.
Does it only film what's in the red square?
What?
Does it only film what's in the red square?
Oh, I guess so. Any questions so far?
No.
What if I have, I'll squeeze this in here, y to the 4th power? What would that be, Madeline?
It would be y times y times y times y.
That's right. This, what form is this called?
That's what I was thinking.
Exponential. And this is called expanded. Exponential is this. Expanded is that. Now here we did 5 times 5 gives you 25. Can I solve y times y times y times y?
No.
No, because we don't know what y is.
Go fly.
Any questions? All right. Y'all ready?
Yeah.
Here we go. Buckle your seatbelt. Now, what I'm about to show you, I want you to know, I swear it gets me every time. As a teacher, it gets me every time. And there are times I have to look back at my own notes. When a student will ask me, I'm like, I had to go in my mind and think, okay, which one is it? Which one is it? All right, so here you go. Look how many stars I'm putting here.
Ooh, we've never done 3.
I know, right? Okay.
The most next thing you do is 2.
Yeah.
Here we go.
Be crazy now.
We're dealing with negatives.
Okay.
Negatives.
I probably need to go down.
I've added 3 more stars.
Wow.
I guess I need 2 too.
All right, y'all ready?
Yes, I am.
Okay, before you, I want you to put your pencils down, or pens, whatever, and I want you to just look, and then I'll have you write, okay? -4 to the 3rd power. That is written as -4 times -4 times -4. Don't write anything yet. And you're like, okay, no problem. What is -4 times -4, everybody?
Positive 16.
Positive 16 times -4. I tell you?
Negative, 64, I think.
Yes? Okay. Because we brought down this. All right, do y'all understand that? Notice the parentheses with the exponent. So we're saying -4 times itself. -4, -4, -4. Do Y'all understand that? Don't write anything. Oh, no parentheses. Don't write anything. That would look like this. Times 2, 2, 4, 5, 6. You would do 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16 times 2. 32 times 2. And the answer will always be negative. All right, you have to be able to distinguish the two. If there's parentheses, it keeps a parentheses. If there's no parentheses in a negative, the negative goes on the outside. You do all the 2's, and then you carry over the negative. You may write.
Not that bad.
It's not, except people tend to forget. So make sure your notes are nice and neat.
I just realized there are 2 different problems with the same answer.
Yep.
I think what makes it a little easier, like to remember like which one is which, is that like when on the first one, it has like the parentheses around, like separating the 4 and the 3, so you know it's going to be 3 separate ones because they're separated, and then the 2 and the 6 aren't separated at all, so it's going to be all in the same one.
So one of my former students, lives right where, I mean, she's an adult now, but she lives right where the eye of Hurricane Ida went through. Like, it was all over the news and everything. And she told me right when the hurricane made landfall that, you know, she was chilling out on her front porch watching it. Then I didn't hear from her anymore. And so I've been worried. Well, she just then messaged me and she said, I'm okay. I finally had found a way to charge her phone. You know, they couldn't charge her phones, and they have no power, nothing. And so I'm talking to her to find out what she needs. And what I'm thinking about doing is, she gave me the name of a Christian school there. And I'm thinking about reaching out to them to see what their needs are, maybe doing a collection and taking it down there. So that could be fun. Okay.
Class field trip.
Can we go on?
Oh, no, not a class field trip.
Yeah, it'd be fun.
I'm not taking you onto that area. That's not a very, it's roads still.
I've been to
mess.
bad
Get to the
areas.
meaty.
That's bad.
My great grandma was buried in a very bad area.
Oh no, I'm not talking about like I'm talking about like because a hurricane just went through that.
Yeah, we gotta see
All right.
that.
So example. Let's do another example. -3 squared. How would I write that? Raise your hand. Someone besides Atalia every time.
You're
Tanner?
skipping me.
Write it down first. I think it would be -3 times -3.
You are absolutely correct. -3 times -3, which would give you what, Tanner?
It would give you positive 9.
Yes, ma'am. Rock and roll. What if I did this? Atalia? You don't have to raise your hand, just call it on you.
Okay, so you put a negative sign, and then you put a parentheses bracket, and then 3 dot 3, and then another parentheses, and equals, and then -9.
Excelente. Notice Look at the answers, positive 9 and negative 9. But look at how the negative 3 squared and negative 3 squared. Ah, do you see why it can be confusing, y'all?
Yeah.
This has parentheses where this doesn't. And yet this gives me a positive 9, that gets me a negative 9.
Oof.
Yes. It will happen. And I'm telling you, your teacher, me, I will sit there and I'll have a kid tell me, Miss Rogers, which one is this? Go back and look. You know, and it's just when you're in the middle of doing all this other math, I'm more excited when a student says, oh my gosh, that's right, there's special rules, than forgetting that there's special rules. So if you have to look back in your notes or your book, because they have this also in your book, that's okay. Don't think there's anything wrong with you. All right, so I'm going to put a box around this so that y'all can, like, when you're looking through your notes, you'll see this again. It'll, like, stand out, and all the stars. That's why I put that there.
Well, mine are on 2 different pages.
Okay, that's okay. How are y'all feeling about this? A little bit,
Nervous.
doing okay?
Nervous.
No, don't be nervous. All right, okay, here we go. Put on your seatbelt. Here's another one. See, that's what today is. Taking baby steps into all this information. Tanner, you got this, girl.
You can do it.
This time I'm doing 3 stars, not to, get confused with negatives. Now this is negative exponents.
Yuck. No. No.
No.
What's like 3 to the negative second power?
Oh yeah.
No. That's nasty. Oh.
Okay. Negative exponents. I'm just gonna give you an example. Now Tanner, don't freak out. Look, she's already getting quiet. Don't freak out. You ready?
No.
Yes, you are.
Yes.
Let's say I have 2 to the negative 5th power. Joseph, do you like seeing a negative exponent?
No.
Then put your hand down. We're going to get rid of it. I don't like it either. So we're going to get rid of it. Do you know how to get rid of it?
Get rid of it.
You just take it away.
Yeah.
You put it on the bottom. You put it in a denominator, like a fraction, under
Yeah.
1.
This is even weirder.
This is a whole number, right?
Yeah.
If I ever want to make a fraction and make this I'd put it over 1, correct?
Yeah.
Okay, then if you want to get rid of that negative exponent, put it on the bottom. Flip it, exactly. Now it's 1 over 2 times 2 times 2 times 2 times 2.
Which is
Atalia?
25.
Nope.
Wait. Back to.
That's what you do. If you have a negative exponent, just whatever it's attached to, that base, you put the whole thing under 1, write it out, and solve. Well, wake up.
Same.
What if I have... Oh, here we go. I'm going to blow your minds now. You have a question? Oh, girl. All right. What if... I'm going to keep teaching, though. What if I have this? Tanner. Oh, no. There's another negative exponent, but this time, Tanner, it's in the denominator. What can I do to make it positive? What do you think?
Flip it.
Flip it. This time, see here, I put it on the bottom. This time, I'm going to put it on the top and make it positive. So that's 3 times 3, which is 9.
You can you just like take it? Couldn't you just like remove the negative automatically?
No, because look, this is in the denominator. It started out in the denominator,
But would it really matter?
and I need to move it up. No, it would, because if I just removed it, don't write this down.
Okay.
I'm going to say flip. Let's say this is my problem. And y'all are saying just remove it. That would give me 1 over 9.
Well, that's like not worrying about the fraction portion. Just
Well, you
solving
have
it
to
in
worry
part.
about the fraction portion.
Well,
So
like,
if the negative is in the denominator, bring it on top, make it a whole number, and then figure it out. If the negative is on the top, put it on the bottom, like as a denominator in a form of a fraction, and then work it out.
So when we're like solving it and it has to show your answer, do you have to like actually show it? Or
Yep,
just
you
do
have
it
to show
in
all your work.
That's dumb.
Let me show you this. What if I had 2 to the negative 5th power over 3 to the negative 2 power? Oh,
Wait a second.
someone else. Let me see. Madeline, do you or Joseph know what to do, or want to take a guess?
Well, maybe you take each one, like out and create its own little thing for it.
Okay. And what? But let me ask you this, Madeline. How am I going to make this positive? Where do I need to put this whole thing? On the bottom. How about this? How do I make this positive? Where do I need to put it?
The top.
On the top.
So you just switch them.
So we're going to do a flip-a-roo. Watch this.
Yeah.
I'm going to move this on top to make it positive, and I'm going to move this on the bottom to make it positive.
Still looks like 32 when I wrote it.
There's my answer.
I just like it whenever. Well, I don't necessarily like it, but like whenever someone blow your minds, then I understand it, and everything. You're like, no, not you.
That's okay. But do y'all understand this? If it's on top and it's negative, you bring it on the bottom. If it's on the bottom and it's negative, you bring it on the top. Let's do another example. What if I had 2 to the negative 2 exponent over 3 to the positive 2 exponent? Uh-oh. Tanner, do I need to move this one anywhere? Why not?
Oh, you move it to the top
Why?
because it's already positive
So do I need to move it anywhere?
to the top.
Why? I moved this to the top because it was negative, and we need to make it positive. Is this negative? So do I really even need to move it? Exactly. I want y'all to notice this. The exponent is positive. Man, I don't need to move it anywhere. What about this one, Tanner?
Just bottom.
Okay, so look at how it looks. Is there going to be anything left on top? No. I'm going to have a 1 over 3 squared times 2 squared. Because I had to move this to the bottom to make it positive. So that's 1 over 9 times what?
4,
And what's 9 times 4?
36.
So you're only going to move the ones that have negative exponents, either up or down, up or down. If they do not have a negative exponent, you just leave it be. Okay? Any questions? Do you see why I said I started the whole lesson off with, here's my proto page, Here's the IXL links that you can use to practice this stuff. Because it's a lot. Yes, ma'am.
What if it's the opposite? Like there's not a negative on the top, but there's a negative on the bottom.
Okay, let's do it. I don't care how many examples we do. All right, Tanner, wake up. So let's say it's 2 squared on top and 3 to the negative 2 on the bottom. Natalia, what do I need to move the 2 squared?
So would it just be like
So wait. Why, Tanner, pay attention. 2 squared. Natalia, why do I not need to move this? It's already positive. But do I need to move this one? Because it's
negative.
because the exponent's negative. Where do I need to move it to?
The top.
On the top. We're going to move it on the top. So now what I have is 2 squared times 3 squared
Over 1.
over 1.
4 times 9.
Equals,
36 over 1.
which is,
36 goals.
there you go.
Smells like Sprite in here.
Could smell worse.
Could smell like 36 goals.
All right.
It's not that bad.
It's not that bad. Simplifying expressions. Oh, goodness. Example. What if I have 3 to the power of 4 minus 4 to the power of 2? All we're doing here is simplifying. This would be 3 times 3 times 3 times 3 minus 4 times 4.
She looks at me, fell back in their chairs.
Who can tell me what 3 to the power of 4 is? Natalia?
It's 81.
Yeah, man. And Tanner, what's 4 times 4?
16.
Yeah, man. 81 minus 16 is what, Madeline? I'll let you work it out on your paper.
Okay. They say yeah, man, a lot of makeup.
I know.
And I got stickers.
Yeah,
Oh,
man.
In Jamaica, there was this lady, she had collecting food on the head.
Madeline's working.
You okay? Yes. This is fine.
Yeah, man. There you go. So that's simplifying expressions. You're just working it out. Any questions so far? All right. Here's a good one. Negative 5 squared plus negative 2 squared. Are the exponents negative?
No.
The bases are. Uh-oh. Remember those rules?
No.
See?
Yes.
All right, Joseph, what should this one look like?
Oh, wait, yeah, I do.
So it should be negative then 5 times 5.
Excelente. What about this one?
So it should be parentheses
It'd be negative 2.
times negative
Yes. I put these brackets to denote that these are together. So what would this be right here, Joseph? Excelente. And what is negative 2 times negative 2, Joseph? And Madeline, what is negative 25 plus 4?
Negative 21.
Yeah, man. There you go.
This is a lot more than 2 pages.
Okay, so we're going to pause right there and tomorrow do part 2.